Hello, good morning, good afternoon, depending on how late it was yesterday. You probably noticed there's a mistake in the scheduling applications. They mentioned this is a session. Actually, this is the closing keynote of DevOps. So, well. And on the closing keynote, we talk about cool stuff, next generation stuff that's tangible so that you can use already now. So, what about real cross-platform Java that you can run on mobile devices? I'm Johan Vos from LodgON, and with me is Niklas Turning from Robo VM. So I'm doing some Android stuff, and Niklas is doing some iOS stuff, but we cooperate together on many points. So what we are going to show today is JavaFX on mobile devices. JavaFX in particular and Java in general. Now, why would someone use JavaFX on mobile devices? Well, first of all, maybe first the question, who is using JavaFX at this moment? Okay, and who is writing applications for Android? Thanks. And who is writing applications for iOS? And who was just here because he was in the previous session and was too tired to get up? Once again, your honesty is appreciated. Okay, so JavaFX is the Java Client API. So it's part of the Java SDK, and it's it's actually the successor of Swing. So in the past, when you created the Java Client application, you were using Swing. Today, you're using JavaFX, which is written. It's a pretty relative young language, and it's written with many other frameworks, with input from many other frameworks. And one of the consequences is it's extremely powerful and fast because it leverages the hardware, the GPU, and the multi-core functionalities of today's processor. So it's a UI framework that's extremely fast. And very important for Java developers, it's cross-platform. So you only have to write your application once, and it can run on different devices. Different devices like, for example, the laptop, the desktop, Linux, Windows, Mac, but also embedded devices and mobile devices. So that makes it pretty cost efficient. If you have to deploy, if you have to write an application, and in case you have to write a web application for it, and then a desktop application, and an iOS application, and an Android application, it's going to cost quite a lot. So having one application is much more, it's much cheaper, and especially the maintenance is much cheaper as well. I already said that JavaFX is powerful, and yada, yada, yada. It's open source, that's important as well. So all the code of JavaFX is in open source. All the commits from the developers, from the Oracle team, from outside Oracle, they are open. So the drawback is that you won't be surprised all of a sudden, because when you develop things in the open, everyone can see it. So in the past, when things were closed, it was always fun to go to Java 1 or the DevOps closing keynote, and then a big announcement would be made. But since everything in the open is now, everyone can track what the team is doing. So, but I think that should reassure you that this is not something secret being developed by a big company. No, it's there, it's in the open. You can take it, you can look at it, you can improve it. So I think there's definitely a big use case for JavaFX on the mobile. I think if you're a Java developer, and there are 10 million Java developers there, you have a language now. You don't need to learn a new language. You can use your existing Java skills to write mobile applications. So why would anyone write a mobile application? Well, today, in the past, most of the usage of the internet came from desktops and laptops. But today, we see that mobile devices are becoming more and more important. And mobile devices can be a phone, can be a PDA or so. So mobile devices outnumber desktop and laptops. And on the mobile devices, it turns out that people are not using the web browsers that often. They're using native applications. People want native apps and not the mobile web browser. Well, from my personal experience, I only use the web browser if there's nothing else. But I really prefer native applications. So if you combine this, mobile applications for mobile devices, of course, are changing our industry. So, well, the majority of the mobile devices are either running on iOS or on Android. So if you combine this, this means that you as a Java developer now have access to write client applications that are running that are initiating the majority of the transactions on the internet. Because tomorrow's transactions will be initiated from mobile devices, not from desktops anymore, but rather from PDAs or mobile phones. And on the back end, so it's pretty easy with your Java skills. You can connect your mobile applications to existing backends, and that's often where the business value is. So the whole business chain, the value chain, makes much sense with Java on mobile devices. So a bit of history about our porting effort. The code for JavaVex is kept in a repository called OpenJavaFX, and it's a sub-project of OpenJDK. OpenJDK is a repository that contains the Java source code for the core Java SE. However, there is no official release from Oracle for Java on mobile. If we stop the recording for 1 second, click. Oracle has a competing product in that space that makes much more money for them. Click, we're back on the recording. So Stefan, you're gonna cut this? So good enough, the code was there. And the community stepped in and helped with releasing the bits. And as a consequence, the JavaFX A220, which is at this moment, well, Java A220 is installed on many devices. And the source code for this release is almost exactly the same on, what's it called? It's not called Apple Macintosh anymore, I learned. It's called Mac OS X. I must have missed a few 10 years or so. So on desktop, laptops, and on mobile, you use the same source code for JavaVex. As a consequence, if you write an application on the desktop, it's going to work on mobile as well, because it shares the same source code. It's important to know that we just started. Well, with our mobile ports, we just started. Good enough, most of it was already there, but bundling it, writing the build tools, and so that's a process that we started recently. We with the community, and then me as being the Android maintainer, and Niklas being the iOS maintainer. So it's not easy to show it without really showing the device. So those of you that know JavaVex probably know the ensemble demo. We have this on an Android device. So this is the showcase of all the JavaFX functionalities. It's not a really... I have to keep it like this now. So it's not the most sexy application, but it shows the functionality of JavaVex. And if I can go back, can I go back like this? For example, what do we have here? Yeah. So those typical JavaVex images that you're used to, these are all working on. Does this do something? Yeah. See, this is a clock, and actually, I never showed this example before, but it's working on an Android device, and it's also working on.
Yeah, this is the same on an iPad. I don't know where you found that sample, but
yeah, I didn't know it was in there. So if you go to the Google Play Store, you can download this sample. So it's an APK that's been uploaded to the Google Play Store. So if you look for, I think, org JavaVex exports, you will find that sample. That's just to show that we're not talking about slides and code only. No, it's really on applications. So now I'm briefly going to talk a bit about the internals of Android, and then Niklas is going to talk about the Robo VM internals. So on the Android devices, we currently, mark the word currently, run on top of Dalvik. So Dalvik is the, can anyone describe what Dalvik is? Maybe someone from Oracle. Yeah, it's still being recorded, so I'm not going to help you getting fired. Dalvik is the Java, but not so Java from Google. It's almost the same, and mind the word almost, as Java 7 currently, but it lacks some classes, it lacks some methods. So it's not really the full Java SDK, but more or less Java. And on top of this Dalvik runtime, we have the JavaFX framework. The native code is cross-compiled to ARM, and it runs on the Android devices. We use OpenGL for doing most of the rendering, and we directly tap into the Android OpenGL implementation. Because there's some missing clauses, we had to add a library, a compatibility library, that we bundled with the JavaFX SDK for Android. And that gives you the missing clauses that are required for doing the JavaFX applications. You don't need to write any new code because the SDK contains the launcher logic. So we will make sure that your existing, the SDK, make sure that your existing JavaFX application is picked up by the Android activity. And it will be started and lifecycle management like any other Android application. We have build tools, and they are also part of the Dalvik SDK. So if you go to javafexports.org, we will mention the resources in the end, you will see a link where you can download the SDKs, both for Dalvik and iOS. So how do you create a JavaFX application for mobile? At this moment, we use both Cradle and Ant, and for some parts you have to use Cradle, for other parts you have to use Ant. I will, if the demo gods are with me, I will show it on a real device. It's at this moment, it's not extremely complicated, but it should be simpler, and we're working on it. And actually, this week at the Hacker Garden, we had some people together, mainly people with Cradle skills, and we are now almost there for having this built with a few lines of Cradle code. There's one issue that we're waiting for to be solved in the Cradle Android plugin, but it's we're almost getting there. So until we have it fully deployed using Cradle, you still have to do 3 steps. First of all, I think that's reasonable, you have to create your JavaFX application. That's something that the SDK cannot do for you. Second, if you have the JavaFX application, we use a Cradle script to create an Android project based on this application. Because that's the way that Android works. You have a project directory with some meta information, with some resource files, and that is what's been automatically created with this Cradle script. Next, you go into that Android created project, and you compile your APK. APK is the format for Android applications, and it's that's the thing that you then upload to the Google Play Store. So first the application, then making an Android project out of it, and then building the APK. Those are the 3 steps. And of course, if you later on change your JavaFX application, you just rebuild the APK, and it works. So the JavaFX application can be any JavaFX application. At this moment, you still have to use the Java 7 APIs. And that is because we're running on top of Dalvik, which provide only support for Java 7. Well, mainly Java 7. Not everything from Java 7 is implemented, but mainly. Good enough, you can use Lambdas. So you can't use streams and the Java 8 APIs, but the Lambdas are supported because we use some great tool which is called RetroLambda, and this will take the Lambdas out of the code and replace them at bytecode level. So the invoke dynamic bytecode is removed and replaced with static. There's an extremely slight performance drop, but it's the good thing is that you don't have to, well, you can still use your Lambdas. And you don't have to do anything for this. because that's part of the build process. So in the build process, when compiling everything, transforming it to Android DEX format, we apply this retro Lambda step. You have to make sure that you create a jar from your application, and the required dependencies, they should be in the same directory as the jar file. And if you're using Gradle, that's very easy. Now, how many people here are already using Gradle? Okay, that's quite, so I think it's really picking up, because it's important for us to know, because if we standardize on Gradle, it's going to be much easier for us. Are there people that are using Maven mainly at this moment? Okay, bad question. Are there people that plan to use Maven in 6 months from now? Okay, good. I think the Gradleware. Are there people? Do you want to move to Gradle? I think would that be a good choice? Okay. Yeah. Excellent. Well, you know, the good thing is the recording goes this way and not that way. So for the record, all hands went up when I asked who is going to support Gradle in the future. So, whew. Okay, now time for something completely different, a demo. So how do we do this in practice? I will show how we run a JavaFX application on Android. Well, that is how we create an Android package on our day-to-day Java development environment. Disclaimer, I'm not a Mac OS X user. I use Linux, but I have problems with displaying on big screens with Linux, so I borrowed a Macintosh computer from a colleague of mine. Still, it's rebranded to Mac, I think. So, what we have here, thanks to Gert-Jan for helping me increasing the font size of NetBeans on Macintosh. What we have here is the JavaFX application that we're gonna show. It's very simple. It's probably the most simple JavaFX application that you can imagine, and it's. Wait, can I move this a bit away? So a JavaVex application is just a regular class that extends application. An application is then a JavaVex application. It has a start method that will be called when the environment says, okay, now you're going to start. In the desktop case, this is well, very common. In the Android case, the Android application manager will call this start method because we provided the hooks for it in the SDK. So you don't have to worry about how this gets started. You just have to know that at one point in time when the user wants to start your application, this method will be the first one to be executed. So what we do here is we don't use any Android code, as you can see. This is only JavaVex code. We first get the screen, and we then ask the visual bounds of the screen. The reason I do this is because on Android we always want to go to get the maximum of the screen that we are allowed to use. We create a label, which is a simple JavaVex control, and we translate that 30 pixels south. We create a button, and we set the text "Hello Android" on it. And then we define the action on the button. As you can see, we use a Lambda expression here. If the user clicks the button, we will set the text of the button to "you clicked the button." That's all I could come up with. Because, again, another disclaimer, my visual skills are not what I hoped they would be, or at least the world is not ready for my UI design yet, so it's gonna look ugly. I mean, correction, many people will think it looks ugly. So I think in 10 years from now, the opinion might have changed by then. So we create a rectangle, color it light blue, make it a little bit rounded corners, and then we create a stack pane where we add our rectangle, the button, and the label. Then we create a scene, which is the Java root element in the scene graph, and we supply that stack pane to it, and we also tell it the width and the height that we want to use, and that's the maximum that we can get. And then we put the scene on the stage, which is an object that is passed to us in the start method, and then we show the stage. So this is just JavaFX introduction. It's just the hello world. Let me see how we can run this application. I have to increase this as well. But someone already told me if I use Command plus, yeah. Can you read it from the back? Okay. Good. That means that you are still awake after a whole week of DevOps. Great. So the application is in this directory. So it contains a source directory and a build.cradle. I will show the build.cradle first. So it's not a big file, and actually you can forget everything that's below here because that's commented out. Might talk about it a bit, but so we say which dependencies we have, where to get the dependencies, and then we say apply the Java plugin, and it's an application, and the main class name is Hello Android. Oh, and also apply the read for Lambda plugin, which is actually not needed because it's going to be automatically. But anyway, if we then want to run this application, I think we can do with Gradle run. And it's going to compile the thing, and it's going to execute it. So, oh, that shows pretty blue on a big screen, doesn't it? But yeah, the hardest part for me was getting a nice color. So if I click on the Hello Android button, you will see that the text in the label will change to "You clicked the button." So that's our application. It's not the most interesting application, but it's also not the most difficult code. Okay, so far so good. Now we have to create an Android project based on this application. And this is actually taken from the samples directory in the SDK that we share. In this sample directory, we have a script named convert JavaFX to Android. And I can show that script. The only thing it does is it sets some parameters like where is the Android SDK, where are we, what's the name of the application, blah, blah, blah. And then it calls Gradle W with those parameters. So it executes the Gradle script that will create the Android directory. I will have to remove it, otherwise it's going to, it's probably already removed. So I execute that script, and now the project directory is created. It's being created in Android, Hello Android, and people familiar with Android will recognize this structure because this is a typical Android project structure. It contains an Android manifest.xml. It's created for you with the values that you supplied and with some defaults. If you want, you can modify it. For example, if you need more permissions, you can add those permissions here. But for our applications, this is perfect. The only thing we have to do now is type and clean debug, and now it's going to create the on this system. I don't know how to change the default path on Macintosh, so it's I have to type the full path. So and clean debug will compile the Java code into Android DEX code. So you see, read for Lambda step is automatically applied. So we didn't have to do it in the Java step. But anyway, while this is compiling, I think it would be good to, for those interested in Gradle, which was pretty much the whole room, in case we have the Gradle support working, we uncomment this piece and we apply the Android plugin directly to our JavaVex application. So we have one Gradle file, one build file for building everything. We apply the Android plugin and we say, and we tell it, use this SDK version 20. At this moment, Lollipop is 21, I believe. And then add the JavaFX, the JavaFX_rt.jar as a dependency. And then, if you then try to run it, it's gonna, to build it, you have all the Android tools, all the Android build tools. So you can build an execute, a debug version, a release version immediately. So once we have this working, that would be great. The thing that's stopping us for now is that our compat library contains java.classes. And the Gradle plugin complains about it. But I was talking to one of the Gradle plugin developers at Google, and they agreed to add this in their plugin. So it's going to be fixed, and we will be able to use Gradle as all of you requested. So going back to this screen, see, typically I have to think, I know that this DEX compilation takes a while, and I have to think about a story that I can tell, and then I come back to that screen, but then people notice, it took 46 seconds, so I can't hide it. Using the Gradle plugin, again, it's going to be compiled incrementally, so it's going to be much faster. As a result of the and debug operation, we have a bin directory which contains hello Android debug.apk. And this is an APK that you can install on your devices, or that you can upload to the Play Store. Well, if you want to upload it to the Play Store, you have to type clean and release and not debug. And then you need to sign it with your certificate, self-signed certificate works, and you can upload it. If you want to check it on a device, you just connect the device, an Android device, over USB. And with the Android tools, there's a application called ADB, and you can install your application to a device that's connected with ADB install. So that's not going to work here because my device is not connected, but if you connect it, it will, so once the device is there, it will install the application, and you can run it immediately there. So, agreed, the build process is a bit complex because you had to type Gradle, convert JavaFX to Android, and clean debug. But still, it's, I think, very much doable. I do it many times a day, and I'm still not sick. So, I think it's not the end of the world. So, one more thing about Android. We often got questions, yeah, that's nice, but also Android has some nice services, which is true. If you look at the Android API, the Java part is only a small part of it. There are many services in Android, like, for example, connecting with the GPS, connecting to NFC reader, media, and that's all nice services. So, in case you wonder, should I make a decision between Java, my favorite language, or Android, which contains more services, but which is not the Java? Then, well, you can mix them because we expose all those Android services, and you can easily use them because there's one class that we added to the JavaFX SDK that's Android specific, and that's the FX activity. And that is the one that behind the scenes will call the start method on your own application. And there's a static method, getInstance, which gives you the Android context. And on this context, you can get the Android system services, like, for example, the location service. Once you have this, you can call the Android location services. So that's a simple way of combining JavaFX and Android services. And with this, I hand it over to Niklas, who's going to explain how something similar is done in iOS.
Okay, so as Jonas showed us, it's quite a challenge to bring JavaFX to Android, but it's still we still have something that resembles a JVM in Dalvik, and of course, Java is the native language when you develop Android apps. So what about iOS? How can we bring JavaFX to iOS? Well, we use RoboVM. Who's heard of RoboVM before? All right. Everyone?
Almost the complete room.
Yeah. First of all, I'm going to give a quick background on the RoboVM project. So the goal of RoboVM is to bring Java to iOS. But thanks to the approach that we've taken, it's also possible to run other JVM languages. So far we've seen that Scala Groovy, Clojure can work to at least some extent on iOS using RoboVM. It's been open sourced since January 2013. It's on GitHub. The license, we use permissive licenses, so it allows you to develop closed source apps that can be deployed to the App Store. And if you're interested in the project, check out the website and make sure you follow us on Twitter. So, at the heart of RoboVM is a compiler that takes Java class files containing Java bytecode and translates them into machine code. We currently have support for iOS ARM, of course, because that's what the devices use. You can also target iOS for Intel 32-bit CPUs, which is what you would use when you launch something in the iOS simulator. There's also Linux and Mac OS support in there, and we're working on 64-bit support. So this is ahead-of-time compilation. It's a process that takes place on your developer machine. Out comes an executable that contains just machine code. There's no interpreter or no JIT. There's no JIT compilation involved when you run this later on a device. So thanks to this, what you get is apps that are performant, they are fast, and consume not that much system resources, I mean, in terms of battery. We've seen that apps using RoboVM are at least as fast as what you would get if you use Objective-C. We've reused the runtime clauses from Android. So all of those packages that you're used to seeing in a normal JVM or in Android, the Java.dot and JavaX packages, for instance, they are there. And they come from Android. So you can do I/O, file I/O, networking. We also have full support for reflection. So this means that, in principle, anything that can be run on Android can also be run on iOS using RoboVM, as long as it doesn't use any of those Android dot packages that are specific for Android, like the Android UI stuff, for instance, or the location service that Johan had on a slide before. With RoboVM, you can use standard jar files. So those, your favorite libraries from Maven Central, for instance, can be used using in your iOS app using RoboVM. Again, as long as they don't rely on anything Android-specific in the Android dot packages, and if they work on Android, it should also work on RoboVM. We also implement the Java native interface specification. Unfortunately, we can't use it as it's defined exactly, because it usually relies on dynamic libraries. On iOS, we can't use dynamic libraries because Apple will reject any app that contains a dynamic library. So we had to base this on static libraries instead. But it's the same interface when you code the header files, and it's the exact same code that you would code in C or C++, for instance. We also provide bindings for all of those APIs that Apple provides on iOS. So everything that you could do if you used Objective-C or Swift to develop your app, you can also do from Java and RoboVM. So Apple provides APIs for accessing hardware, GPS sensors, there's services, notifications, in-app purchases, whatever. Building native UIs using native controls. So you can build an app that looks and feels exactly like what you would get if you had used Objective-C or Swift. There's really no difference. These are all the frameworks that Apple provides in iOS, and we now have bindings for everything. There's some of these have not been updated yet to iOS 8, but most of it is we have bindings for most of it for iOS 8 as well. We also try to make it easy for Java developers to get up to speed with iOS and start developing for iOS. So we try to take as many of the new things out of the equation. So obviously we let you use Java, so you don't have to learn Objective-C or Swift. You should not have to touch Xcode as well. So we try to integrate with popular tools. So there's a Eclipse plugin for Robo VM that I'm going to show you in a few minutes. We also integrate with Maven. So you can do most of the things from Maven. You can compile. You can compile an app. You can launch launch in the simulator. You can launch on a device. You can create a package that can be distributed to the App Store. We also recently added a JUnit support to Maven, so you can actually run JUnit tests on a device using Maven. There's also a grader plugin that has the same functionality as the Maven plugin. And these are all maintained by us. There's also plugins for the Scala build tool and the Clojure build tool that people in the community are working on. There are also some misconceptions about what RoboVM is, so let's kill those. So RoboVM is not something that takes your Android app, your Android APK or whatever, and automatically converts it into an iOS app. You would have to you would have to do this work yourself in some way. If you use JavaFX, most of it can just be recompiled for iOS, and it will just work. RoboVM is not a tool that takes Java source code and translates it into Objective-C. There's other tools out there that does something like this. We work on a lower level, so we take class files and bytecode and translate it into machine code. So the benefit with this approach is that you can use precompiled jar files. You can even go buy something from someone that doesn't want you to have the code for it, and use that in your iOS app. And of course, you can also use other JVM languages that compile down to Java class files, like Scala, for instance. And RoboVM is not only for games. So far, most of the apps that have been built using RoboVM are games. I should also add that it does work great for games. But the reason why there are so many games is that we helped the libgdx community to bring libgdx to iOS. And libgdx is this game development framework that lets you develop games in Java. Using a single code base, you can deploy your game on Android, the desktop, in the browser, and using RoboVM also on iOS. So currently there are more than 100 apps in the App Store that have been built using RoboVM. Thousands of people have downloaded and tried it out. We released 1.0 Alpha 4 a couple of weeks back. This is the first release that adds native support for Lambdas and default methods. So you can now, we don't even need to use retro Lambda. We have this integrated into the RoboVM compiler. And we're scheduled to release a beta later on this year. Right, so now I'm just going to show you some JavaFX stuff using RoboVM. So let me see, sorry. This is Eclipse. I'm not sure if it's, I don't think you can change the text, the font size over here. Do you people in the back see the packages and file names here? Okay, it's not that important. What I have here is the Ensemble app that we saw before on the iPad and on the Android tablet. This is the code that comes from the OpenJFX project by Oracle. It's, this particular project is just an ordinary Java project. So what I'm going to do now is to just launch this in Oracle's JVM. So far, there's nothing RoboVM specific involved or anything. So we're now running Ensemble on this Mac, just in an ordinary JVM. Yeah. So what I'm going to do now is to create a new project that depends on this one. I'm going to add a small launcher Java class that just hooks into the lifecycle of how an iOS app needs to behave, and then just calls into JavaFX and starts the ensemble app. So first I should show you also how to get started with Robo VM in Eclipse. It's pretty simple. You have to make sure that you run Eclipse in a Java 7 JVM or Java 8 JVM. And you need to have Xcode installed on your machine. You should not have to go into Xcode, but you have to have it installed because we rely on some of the tools that comes with Xcode. Once you have those things installed on your machine, just head on to the Eclipse marketplace and wait a bit. And you should just have to search for Robo VM. And there it is. Now I already have it installed here on my machine, of course, so I'm not going to do that. The first thing I'm going to do now is to just create a new project. So new project, I will select the Robo VM iOS project wizard. I need to give it a name, of course. Ensemble iOS. Yeah, okay. It's too small. Yeah, you should see some things down here. For some reason, let me see if I can just quickly change the resolution. I'm going to switch back. I just need to see the bottom of this dialog. Okay, so here in this wizard, we just have to specify the name of the class that's the entry point to our iOS app. So if you don't see this, I just entered Ensemble iOS. That would be the name of the main class. We also have to specify an app name. So, oops. Oh. Okay, let me restart. Okay, new project, new RoboVM iOS project, Ensemble iOS, main class is Ensemble iOS, and then we give it a name Ensemble, which is what this is what we will see in the springboard on the device next to the icon. That's the name of the app. I also have to give it a unique ID, like that. Oops. And finish. So let me just change back to the other resolution. All right, so now we have a RoboVM project. It looks very much like an ordinary Java project, except that we have a different runtime library. So now we have this RoboVM runtime library instead. It contains all of those classes that you are used to see in a runtime library. So we have java.lang, java.io, etc. here. All of these come from Android, as I mentioned before. We also get this RoboVM CocoaTouch library. So this is the library that contains all of those bindings for the Apple APIs. We're not going to use much of that now because we're using JavaFX instead. We also get a bunch of files here. The properties file here just contains the stuff that we entered in the project wizard. We get this robovm.xml file. This contains instructions for the compiler, what to do, what platform to target, for instance. This is where we would add stuff like if we need a JNI library that needs to be linked in, for instance, we need to add it here. Yeah. And we also get this info.plist file, which contains metadata for the iOS app. iOS will read this, and it will know what to display on the springboard and the icon, etc., etc. Anyway, the first thing I'm going to do now is to just add that ensemble iOS main class that we specified in the wizard. So I already have this in another project. I'm just going to copy it over. And it's very simple. It has a main method. It does some stuff here, setting up some JavaFX properties. At the end, it calls into UI application.main, and it specifies an ensemble iOS.class. This is something that every iOS app needs to do. It needs to initiate the UI application main run loop. So this is where UIKit starts up. That's the native UI framework on iOS. We give it the name of a class that it's supposed to instantiate, which contains lifecycle methods, similar to what Android has with activities. So our ensemble iOS is actually an implementation of this UI application delegate interface, which contains the lifecycle methods. So on a launch, iOS will call into this did-finish launching method. And the only thing we do here is to create a new thread, and then we call into the JavaFX Application class. We specified that we want to run the ensemble app class that we had in the other project, which was when we run it on the desktop. Right now we get a bunch of we get some compiler errors here because we need to add, first of all, we need to make sure that this project depends on that other project we saw before. So that should clear up some of the compiler errors. And also we need to actually have the JavaFX classes on our class path. So that's why application here gives us an error now. When we do JavaFX on the desktop, we use Java 8 and we have JavaFX on the class path all the time. There's nothing special we have to do. But for iOS and also Android, we need to have this special jar file available. So I'm just going to copy over this lib folder here to my project. And we have these two jar files here. Johan talked about the compat jar file before. That's the same we use here. And then we have this jfxrt.jar. This contains the slightly modified version of JavaFX that Johan talked about. So we're using the same code that you would use for Android. I'm just going to add these to the build path, and we should see that those compiler errors go away. Okay, so now we have everything on our class path. The last thing we have to do is to make sure that we compile in all of the native stuff that JavaFX needs to run on iOS. So that would be the JNI libraries. And let's see. I have this is something that you add to your RoboVM.xml file. So I'm just going to copy over another one here. I'm not going to go into detail here what happens. But as you can see here, for instance, we have a bunch of libraries here. These are static native libraries that we need to compile in to get JavaFX running properly on iOS. So let's see what happens. Let's launch this. So to launch using RoboVM on iOS is pretty simple. Just right-click the project, run as, and then you have a bunch of choices here. Now, for this demo, I'm going to run it in the iOS simulator, and I'm going to simulate an iPad. So that's what I'm going to choose here. I could have chosen an iOS device. Then, if I had my iPad connected, for instance, it would launch on my iPad. And then you also have the option to simulate an iPhone if you want a smaller screen. So let's see what happens. In the console here, you can see what happens. It compiles It takes the class files, converts them into machine code for the platform that we are targeting. And at the end, it has to link all of the classes and all of the native libraries into one executable. JavaFX is quite a large project, so there will be quite a lot of classes that needs to be linked in. And the ensemble app, of course, it uses everything in JavaFX, so there will be lots and lots of classes that needs to be compiled in. Okay, so now it should be up and running. There's a bunch of exceptions and stuff that happens there at runtime that you don't have to care about. So, here it is. Running in the IO simulator. Yeah, that's it. So let's just you want to take this?
Yeah, sure. So, in summary, everything that's being done both on RoboVM and on the Android port is in the open source. We have a repository, bitbucket.org/JavaVex ports, and a website that that we try to maintain, which is javavexports.org. There you can find the information. Keep into account that especially the last months and weeks, we were very busy with hacking for Java 1, Devox, Gmagrab, and so we should we made many improvements that are not reflected on the website yet. Questions? There's support in Google Groups, both for JavaVex, Android, and for RoboVM. We have two different groups because the questions are typically very different, very specific for either JavaVex or Android or iOS. These questions are very, so we try to answer as much as we can. So it's open source, the community, everyone is helping a bit. We also do questions from companies that really want commercial support, and there's commercial support available, both from RoboVM as well as from LodgON. So if you want to use this in a business application, contact us for helping you with support. So it's, on one hand, it's really an open source initiative. On the other hand, we're very serious about it. So this is not just for fun. We realize the importance. So therefore, there's commercial support available as well. Final thing before we are at the questions, because the first question is most likely going to be, yeah, that's fine that you can run Java applications on iOS and on Android, but I've been to a conference this week, Devox, and I've seen Venkat talking about streams. I've seen Brian Guts talking about Lambda APIs. That was actually Paul Sanders, I think. And I want to use them. Now, unfortunately, on Android, you're using the Dalvik virtual machine, which has no Java 8 APIs. And on iOS, you're using the same Dalvik classes. So I can't use what I learned here. So that's a pity. So before you're going to be disappointed, at Java 1, we announced that we are going to bring Java 8 APIs to the mobile devices as well. So we've been in talks, lots of technical talks. There are still some options that we are considering, but we're now working on having the full Java 8 APIs available on mobile. So that means that as an Android or iOS developer, if you're a Java developer, you will be able to take advantage of the streams and the other things in Java 8. So the next question is then, when will it be ready? Of course, yeah, someone asked, when would it be ready? As Brian Guts would say, when it's ready. So if there are some other questions, we're very happy to take them. We have 6 minutes left. Yes?
How about 64 support for iOS?
How about 64-bit support for iOS? Yes. We got this nice surprise from Apple a couple of weeks ago that from February 1st, every new app and every update to the App Store has to be support 64-bit. So there has to be a slice in the executable that's 64-bit. Yeah, we will try to make it to February 1st. That's all I can say right now. We have Intel x86 64-bit support almost working. So in December at least you should be able to run in the simulator, 64-bit stuff in the simulator. But then there's also ARM 64-bit, which is a challenge. But we'll try to make it for February 1st at least.
Yes. Yeah, so the question is, there have been attempts in the past with Apache Flex and with PhoneGap, for example, which did not really take off completely. I think so. Why would this work? I think there are two important things. One, well, I liked Flex in the beginning, but I stopped using it because it was not Java, and it's so frustrating that you're using Java in some projects and it works fine there, and then you want to use it on the mobile and it's not exactly the same Java, and that's so frustrating. I think this time we use a standard Java API, and those 9 or 10 million Java developers, they don't have to learn a new language or new patterns. They can still use the same. The second part is, and that's something that we didn't discuss this in this session, but we are working with some other people in the community, for example, the ControlsFX guys, to create native controls, native look and feel controls for iOS and Android. If you looked at how I was struggling to push that small back button on that iPad, that's of course because of the stress with a few thousand people in the room. But it's also because that button was just the same button as on desktop. And so we're now working on integrating those mobile controls, which will make it even look more like a native application than before. So that's, I think, a key differentiator that we try to achieve. Yes?
For integrating those mobile-specific services like location services and so on, is it right that you still need a different approach in iOS and Android applications, so there isn't a cross-platform unified approach yet?
Not yet. So far you need to, you should probably rip that out into a separate project of your own, a module, and have an interface or something around it. But we will work on bringing some of these, getting some kind of a unified API. I know that, yeah, I think you said something about that also. I mean, even getting it into maybe a JSON or the JCP.
Yeah, so
process.
I think the end goal is to have those services standardized as well. Now that's going to take a while, but because we have different environments and with people from different environments, the first thing that we try to do is to have an own abstraction layer, and then if we can somehow file this as a JAB or JSR, but that's in the future, of course. At this moment, but that's going to be, well, we didn't have time to talk about this in this session, but we use a service loader concept to abstract the service, the device-specific code. For example, location service on Android and on iOS and on desktop is different. So we abstract this with a general with an interface that's then implemented by different components. There is a location-based example that I showed at Java 1, and that's using the location APIs of Android. And if you look at this, this is called Where's Duke. This is in the Play Store in a beta version. If you want access to it, send me an email. And the source code of this is based on an article in Java Magazine of September, October. It's called OpenMapFX is the code that we use behind it. And that repository, if you go to Java Magazine, you will see the source code. That repository contains how we abstract the location-specific Android things from the generic things. But in the end, it should be, I hope it's going to be standardized. Yes?
What about the new Android runtime?
Art. Yeah, good question. No problem. Actually, well, not this one, but my phone is running on Art, and the only difference is it's going faster, because good enough the Art compilation happens on the phone itself, so the APKs are not changed. So I was a bit afraid when they said Art, and I didn't know when the compilation happens. But all applications that work before Art are still working on Art. So in the end, we're not different from a regular Android application. So we just benefit from Art being there. And you should do it, have it on your phone. Or this one, for example, is not running Art, but my phone is running Art. And if you can disable, enable Art and reboot. And the only thing that you see is with Art, it's going to be much faster, like most of the Android applications. Yes?
Is there any support for pushing whatever you just built to a device and then see what it looks like on the device itself?
You mean on Android? Or?
On any device? Because you show the result in simulators.
Yes.
Not on a real device.
Yeah, for iOS you can connect your device and you can run, yeah, just like I did on the simulator, you can just run on a device instead. It's a bit slower because it takes some time for everything to upload, and so yeah, but definitely.
For Android, it's the same. So I didn't show the last step where I had this ADB command, but if you execute that with a USB cable attached, it's on your device. And on Robo VM, for example, I'm using Maven with Robo VM, and that's extremely easy. It's just Maven iOS : iPad or something. So
yeah.
And then it goes to the device. More questions? Yes?
Could you estimate how difficult it would be to do the same for like Windows Phone or Ubuntu Phone or Firefox?
Okay, I think Ubuntu and Firefox phones there would be based on the Linux version of the JavaFX SDK, so that's not going to be a problem. The Windows Phone would then probably be based on the Windows distribution. So I don't think there's, from a technical point, I don't see a big issue, but I've never tried it. But especially the Ubuntu installs, I think, are pretty similar to the regular Linux install of JavaFX. Are there more questions? Okay, then I think we can officially close DevOps.
Yeah.
Thanks for attending.